China launched a key lunar mission on Friday to collect samples from the far side of the moon. The 53-day mission is the world's first that aims to bring around 2 kilograms of lunar samples to Earth for analysis. For centuries, we saw the moon as just a pretty luminous rock in the sky. But what China's recent lunar missions have discovered will change your view completely. More than anything, the moon is a gold mine of resources, some of which will save our lives. Scientists are analyzing the first fresh moon rocks brought back to Earth in decades, hoping they'll reveal the moon's hidden past and lunar materials that could impact our future. This isn't just about space exploration. It's about unlocking a mystery that could rewrite our understanding of the moon and its potential to help Earth. China's Chang'e 5 found an energy-rich crystal in lunar rocks in recent years. China's Chang'e 5 brought back some lunar rocks, and they found a crystal in there that's unlike anything we've seen before. The structure of this moon crystal seems to have a key ingredient for making nuclear fusion a reality. Deep inside these crystals lies a rare element called helium-3, which scientists believe may provide a stable fuel source for nuclear fusion reactors. The element is incredibly rare on Earth, but it seems to be fairly prevalent on the moon. Described as a colorless, transparent columnar crystal, the tiny sample about 1/10 the width of a human hair is of great interest to lunar geologists. They've named this special mineral Chang'e site, after the mission and the Chinese moon goddess. The next step will be for researchers at the Beijing Research Institution of Uranium Geology to see if we can actually use the helium-3 isotope, a key ingredient for fusion here on Earth. This is a huge development in the clean energy race. Nuclear fusion is a type of energy production that is the ultimate holy grail for our energy needs. Where atoms are fused together instead of split, think of it like combining tiny batteries to make a super battery. That's the kind of power we're talking about. For anyone struggling with high energy bills these days, this discovery could change everything. We currently rely on nuclear fission for a lot of our energy, but it creates radioactive waste, which has raised some serious safety concerns. On the other hand, nuclear fusion releases way more energy than fission, and the waste products aren't radioactive. That's a win-win. Scientists around the world have been chasing this dream for decades, but it's a tough nut to crack. The reason? Making atoms fuse together requires incredibly high pressure and energy, and so far, the amount of energy you put in has been more than you get out. The key here is finding a material that's naturally inclined to fuse more easily, and that might be exactly what we found with this moon crystal. The Chang'e 5 mission was a huge accomplishment, but there's a lot more you need to know. The Chang'e 5 mission launched from Wenchang in Hainan province, the same spot that's seen numerous satellites and even parts of China's space station take flight. It finally landed on the moon on December 1, 2020, after a 23-day journey through space. After separating from its orbiter, the Chang'e 5 lander set down on a vast flat region on the far side of the moon called Oceanus Procellarum, right next to the 5,000 ft high Mons Rumker. Their mission, to grab some moon rocks and bring them home, the first time anyone had done that in 40 years. But this is easier said than done. Chang'e 5 aimed to be the first to snag samples from the moon's deeper layers. Why? Scientists are starting to suspect the moon might hold some big surprises, maybe even a treasure trove of resources that could revolutionize our energy situation. After successfully drilling, the lander sent its precious cargo back to the orbiter, and within 14 days, they were hurtling back to Earth. This mission was a huge win for China's space program, solidifying their place among the world's leading spacefaring nations. Researchers around the globe were excited to analyze these lunar samples, and as you might guess, the hopes for groundbreaking insights about the moon were more than fulfilled. The Chang'e 5 mission returned to Earth on December 17, 2020, landing safely in Mongolia. Scientists eagerly awaited the samples, hoping to unlock the moon's secrets. The big question was, did these samples confirm existing theories about the moon's formation, or would they reveal something entirely new? The leading theory suggests a giant Mars-sized object slammed into Earth billions of years ago, creating the Moon. The impact zone was super hot, supposedly vaporizing any water. This led scientists to believe the Moon was a dry, shrinking rock. It's only recently that scientists have admitted they were wrong. Telescopes and probes spotted huge deposits of ice near the lunar poles. So where did this water come from, and why did it go unnoticed for so long? This discovery sparked a new mission, NASA's Artemis program, aiming to land astronauts near the poles in the coming years. They'll investigate if this water ice can be used. But the Chang'e 5 dropped a major plot twist to this discovery. They found evidence of water not only on the poles, but everywhere on the Moon. The samples contained tiny glass particles formed by meteorite impacts. These might have also hitched a ride on comets, delivering water that's now trapped as ice at the poles. But the real shocker came when scientists examined these glass beads closer. Inside them, water. Each particle holds a tiny amount, but the total lunar water reserves are massive. These 32 shiny, multicolored glass beads were in samples returned from the Moon by China in 2020. The beads range in size from the width of one hair to several hairs. The water content was just a minuscule fraction of that. It might sound crazy, but the research is clear. Each gram of lunar soil contains about 2 milliliters of water. That might seem small, but considering the vast lunar surface, it adds up to a whopping 2 L of water per ton of soil. Under Earth conditions, the best part? These glass particles are likely scattered all over the Moon, thanks to billions of years of bombardment from space rocks. This means water could be abundant everywhere, not just the poles. This shows water can be recharged on the Moon's surface, so there's probably a new water reservoir. Future Moon missions could potentially access water anywhere on the lunar surface, skipping the challenges of extracting ice from the poles. More studies are needed to determine whether this would be feasible, and if so, whether the water would be safe to drink. This discovery by Chang'e 5 is the tipping point for future lunar exploration, potentially making water readily available for human settlements across the Moon's surface. The samples brought back by China's Chang'e 5 mission are truly one of a kind. Not only did they come from deeper lunar layers, but they're also 1 billion years older than anything retrieved by the Apollo astronauts. These tiny glass beads were likely formed in the last 2 billion years by colossal impacts from meteorites, asteroids, and comets. Imagine the kind of smash it would take to create these beads. Think something on par with the asteroid that wiped out the dinosaurs. As a small celestial body, the Moon has taken a real beating throughout its history. It's amazing it survived. Scientists believe the Moon's low density and a thick layer of dust helped cushion the blows. This turbulent past might hold the key to future benefits for us. The Moon's history, as revealed by these deep samples, could be full of surprises that could be incredibly valuable in the years to come. Further investigation into the samples, researchers digging deeper into the Chang'e 5 samples, found something incredible. Evidence that the water trapped inside those tiny glass beads was made by the sun. Here's the theory. Positively charged hydrogen atoms from the solar wind slammed into the beads and mixed with the oxygen already there. Studies of these hydrogen atoms even suggest that the beads can release some of this hydrogen when heated by the sun, a potential future source of fuel. The amount of water locked away in these glass beads is staggering. Estimates suggest a total of 298.2 billion short tons, dwarfing the previous water ice estimates of 6.161.405. Explored that too. As fantastic as it sounds, the Moon's harsh reality makes flowing water unlikely. The Moon lacks a significant atmosphere, has extreme temperatures, and almost no air pressure. Water needs specific conditions to become liquid, and the Moon just doesn't have them. The Moon's low density and weak magnetic field also suggest these conditions won't change much in the future. Mars, on the other hand, tells a different story. Evidence suggests liquid water once flowed there, and some ambitious plan even proposed terraforming Mars using an artificial greenhouse effect to melt the polar ice caps and create oceans. However, even that's a topic of scientific debate. But back to the moon and Chang'e 5's incredible discoveries. Those glass beads held more secrets than just water. Stay tuned, because the next revelation could trigger a lunar rush, mining the moon. The Chang'e 5 mission has ignited a burning question. Could the moon be the key to solving Earth's resource problems? Imagine daily moon rock deliveries giving our planet a chance to recover. It's still in its early stages, but China's Chang'e 6 mission, which recently launched in May this year, aims to collect even more samples from the moon's far side. This is definitely something to watch, and let's not forget NASA is paying close attention too. Helium-3 is the most important discovery here. Experts believe just 27.6 tons of this isotope could power the entire US for a year. That's roughly the amount a space shuttle can carry. The estimated value? A massive $3 billion per ton. Abundant, low carbon, and with minimal waste. That's the potential held by helium-3, the rare isotope found in lunar dust. The buzz about this is far from recent. It's been happening since the 1980s. Scientists have always speculated about its possibilities as a fuel for nuclear fusion reactors. Wang Zhaowen, a prominent scientist in China's space exploration program, has repeatedly emphasized the potential of mining helium-3 on the moon. According to the scientist, successful lunar helium-3 extraction could theoretically provide enough energy to meet global needs, potentially requiring 3 space shuttle missions per year. Over billions of years, the solar wind has been showering the lunar surface with high-energy particles, including helium-3. It's constantly being refilled by the sun. This discovery has the potential to trigger a lunar gold rush, attracting nations and companies eager for a piece of the pie. Major energy corporations are already showing their interest in NASA, hinting at potential investments in future space missions. This could be a major boost for NASA's Artemis program. But there's a catch here. While technically a renewable resource, the amount of helium-3 on the moon is surprisingly low. Studies show concentrations can be as low as 4 parts per billion, which isn't exactly a gold mine. But nevertheless, even a small quantity contains massive amounts of energy. This means there's a lot of work to be done. Scientists need to figure out if it's even possible to extract helium-3 from the moon in a way that makes sense. The potential rewards are huge. A clean, powerful energy source that could revolutionize our future. But before we get carried away with visions of lunar mining empires, there's a lot to consider. Is this a sustainable solution or a race for the next big resource grab? Only time will tell. Chang'e 6 mission. On May 3, 2024, at 5:27 p.m., Chang'e 6 blasted off from the southern island of Hainan with an 8-ton probe. This nearly 2-month mission marks a world first. The Chang'e 6 probe, also named after the moon goddess in Chinese mythology, is a marvel of engineering, much like its predecessor, Chang'e 5. It's a team effort, an orbiter, a lander, and an ascender working together to collect samples and return them safely to Earth. Now that it's in lunar orbit, Chang'e 6 is about to embark on a critical phase of its mission. The spacecraft will team up with China's recently launched Queqiao relay satellite to perform precise maneuvers in lunar orbit. This will ensure a smooth separation of the lander and ascent stage from the orbiting probe before their descent to the lunar surface. Their target? The South Pole Aitken Basin, a shadowy region on the far side of the moon. This mysterious area has remained largely unexplored due to its constant turn away from Earth. In 2018, China made history with the Chang'e 4 mission, the first ever robotic landing on the far side. In 2020, Chang'e 5 became the first mission in decades to bring lunar samples back to Earth. Now, Chang'e 6 aims to be the first to obtain samples from the moon's hidden side, further solidifying China's position as a major player in space exploration. China's space agency, CNSA, already has the U-22 rover on the far side of the moon, which landed in 2019 as part of the Chang'e 4 mission. U-22 has already made some big finds, including the discovery of small glass spheres on the lunar surface. Details of the mission once it touches down. Chang'e 6 will spend 2 busy days collecting a treasure trove, 2 kilo or 4.4 lb of lunar samples. These samples, estimated to be around 4 billion years old, hold the potential to reveal incredible secrets about the moon's formation and history. Once the lunar samples are collected, they'll embark on the next leg of their journey. A special re-entry module aboard the Chang'e 6 orbiter will act as a protective shield safeguarding these unique samples as they blaze back through Earth's atmosphere. Following this fiery descent, the probe's engine will roar back to life, performing a transfer burn. This crucial maneuver will nudge the spacecraft onto a precise Earth return trajectory, bringing it back home. If all goes as planned, Chang'e 6 will conclude its 53-day mission with a triumphant touchdown on Earth, carrying the first-ever moon samples retrieved from the far side. This historic achievement will be a major milestone for China's lunar exploration program. Chang'e 6 marks the 5th successful moon mission by China since 2018. It's a stepping stone towards their ambitious goal, landing a team of taikonauts on the moon by 2030. The future of lunar exploration is shining bright, and Chang'e 6 is helping pave the way. But Chang'e 6's mission goes beyond immediate discoveries. It's a crucial step towards a long-term vision, building a permanent international research station on the moon, known as the International Lunar Research Station, ILRS. This ambitious project, led by China and Russia, would pave the way for even deeper lunar exploration. China's space program is clearly accelerating. Their ambitions include landing astronauts on the moon by 2030, retrieving Martian samples, and launching 3 more lunar probes in the next 4 years, with the next one scheduled for 2027. Hidden spacecraft. There's another detail that makes China's Chang'e 6 mission to the moon's far side even more exciting. After launching in early May, it was revealed that the spacecraft is carrying a previously undisclosed mini-rover. This surprise addition wasn't part of the initial mission plans, which focused on collecting and returning the first-ever lunar samples from the far side. However, following the successful launch, images showed the tiny rover nestled beside the lander. Chang'e 6 is actually a repurposed backup from the Chang'e 5 mission, which successfully collected samples from the near side of the moon in 2020. This repurposing strategy is similar to how China landed Chang'e 4 on the far side in 2018, using a backup from the Chang'e 3 mission. The Chang'e 6 mission is already packed with international collaboration, carrying scientific instruments from France, Sweden, Italy, and even a Pakistani CubeSat. Now, with the addition of the rover, it becomes even more fascinating. Details about the rover are scarce, but a post from a Chinese research institute hints it might carry an infrared imaging spectrometer. This fancy tool uses the way different materials absorb and emit infrared light to identify the composition of rocks, soil, and lunar dust, potentially even detecting water ice. Exactly how this little rover will disembark from the lander onto the lunar surface remains a mystery. It could be released, climb down a ladder, or use another unknown method. Communication with the lander might be handled through Wi-Fi. Given the rover's compact size and the mission's limited duration, its operational time and scientific goals will likely be brief. China's history with surprise packages. China's space program has a knack for packing extra surprises into their missions. The Chang'e 6 lunar mission isn't the first to unveil a hidden bonus after launch. Remember Tianwen-1, China's ambitious mission to Mars? It kept dropping surprises throughout its journey. First, they released a small expendable spacecraft that captured stunning deep space photos of Tianwen-1 itself as it cruised towards the red planet. Then, even after landing the Zhurong rover on Mars, the surprises continued. Zhurong dropped a tiny camera that snapped a picture of itself beside the rover, sending the image back via Wi-Fi. Finally, even the Tianwen-1 orbiter got in on the action, deploying another detachable camera to take a selfie while orbiting Mars. With the unexpected rover reveal on Chang'e 6, it seems China's fondness for mission bonuses is here to stay. How does NASA's lunar mission play into this? Chang'e 6's mission isn't happening in a vacuum. All eyes are on it at the moment. The U.S. space agency NASA is also aiming for the moon with their Artemis program. Their plans include crewed missions, a lunar flyby with Artemis 2 in 2025, and a moon landing with Artemis 3 in 2026. This ambitious agenda has sparked talk of a new space race, with even top NASA officials like Bill Nelson chiming in, particularly since China is aiming for a crewed moon landing by 2030. In an interview, the NASA chief stated that he thinks it's possible China will be the first to get their boots on the moon, but wonders whether it'll be a collaborative effort. He said that he and many others are worried about resource claims, remembering the territorial disputes over the Spratly Islands. Nelson emphasizes the importance of keeping the moon, and Mars for that matter, open for everyone. The U.S.-led Artemis program is still very much on track, with a target of landing astronauts near the moon's south pole by September 2026. There were a few technical hurdles to iron out after the first mission, but that's par for the course in any new endeavor. Speaking of endeavors, Artemis is partnering with SpaceX and Blue Origin. So is it a space race 2.0? Maybe not. Maybe it's more like a giant leap for all mankind. Biden seems to have continued all the Trump-era space programs, including the Space Force and, of course, the Artemis program, which aims to send the first woman and person of color to the moon. With 39 signatories, the Artemis Accords have become a significant international agreement for space exploration. This surpasses the number of countries involved in China's lunar exploration program. The growth of the Artemis Accords suggests a potential for renewed international collaboration in space exploration, which could yield benefits for all participating nations. Meanwhile, a long-term project, the International Lunar Research Station, ILRS, is being proposed as a collaborative alternative to the U.S.-led Artemis program. This joint effort between China and Russia has garnered interest from other countries as well. As of March 2024, 6 nations have joined, including South Africa, Pakistan, Egypt, Belarus, Venezuela, and Azerbaijan. The lunar samples from Chang'e 5 and 6 put China in a unique position for international space diplomacy. Even NASA, after receiving government approval, applied for samples from Chang'e 5 in late 2023. So it's not all about competition, but collaboration. There's no doubt that scientific institutions around the world will be even more eager to get their hands on the first-ever moon rocks from the far side, retrieved by Chang'e 6. These samples could offer an unprecedented glimpse into this mysterious hidden region of the moon. International collaboration, China's historic Chang'e 6 mission, carried scientific instruments not just from China, but also from France, Italy, Pakistan, and the European Space Agency, ESA. This international collaboration on Chang'e 6 just goes to show the moon's increasing importance as a future resource and scientific frontier. While the U.S. wasn't involved in this specific mission due to legal restrictions, Chang'e 6 is charting a course for a fascinating journey. After separating from the rocket, the probe will take about 4 to 5 days to reach lunar orbit and land on the moon in early June. The country China's collaborating with the most in its space ventures is Russia. In fact, they're even planning on building a nuclear reactor on the moon. It sounds like something out of a sci-fi flick, but it's very much a real possibility. The lunar nuclear reactor will be built by 2035 and will provide power to their jointly operated lunar base, the ILRS. While the ILRS was touted as open to all interested countries, current tensions make participation by the U.S. unlikely. Frosty relations with China's space agency, CNSA, and the recent split with Roscosmos over the Ukraine war, which will see Russia leaving the International Space Station by 2025, likely exclude NASA astronauts for the foreseeable future. The construction job would likely be carried out autonomously and without the presence of humans. The experts on both sides claim that necessary technological solutions to pull this off are almost ready. The only holdup is that they haven't figured out how to make nuclear-powered spacecraft to get the building material there safely in the first place. They emphasize that it's important to create a reliable, long-lasting, and long-term source of energy on the moon because solar panels can't store energy to keep electrical appliances running for long. One lunar night lasts about 14 Earth days, after all. What does this mean for the space race? China is the only nation to successfully land spacecraft on the moon since the Russian Luna 24 mission in 1976. Not only that, but they would be the third nation to bring rocks back from the moon. Simply landing on the moon is a difficult feat, but on top of that, there were so many other challenges that had to be overcome. But since China successfully overcame those, it's very likely that it could beat out its competition. Chang'e 6 is the fourth Chinese mission to land on the moon. There's also a satellite and an orbiter hovering over the moon, bringing the total number of Chinese robots near the moon or on it up to 8. Russia and the European Space Agency want to do things on the moon too, but they're far behind in terms of delivering on those plans. So, China's real competitor is America for now. Plans for Chang'e 7 and Chang'e 8 missions are also reasonably well advanced and will continue to embrace international cooperation for the future. Chang'e 7's mission, 6 payloads from 7 countries have been selected to board already. The next decade will likely see a surge in lunar missions, gathering data on the moon's rocky surface or regolith in unexplored areas. This information is crucial for the future of space exploration, particularly regarding the potential of utilizing extraterrestrial resources. However, exploiting these resources faces significant hurdles. Developing a lunar mining industry is currently cost-prohibitive. Existing renewable resources on Earth remain more practical due to the high investment and infrastructure needed for extraterrestrial mining. Even factoring in potential future advancements, the energy required to extract and utilize lunar helium-3, for example, for fusion reactors, would likely limit its overall contribution to global energy needs. Despite these challenges, ongoing research and development programs keep the option of lunar mining open. Technological breakthroughs could change the equation, making it economically viable in the future. However, current international treaties lack regulations for lunar mining activities. In the meantime, discussions are underway to establish a legal framework similar to Antarctica's, a neutral zone dedicated to scientific exploration. So what's next for the lunar mission? China's lunar exploration will continue with the exciting Chang'e 7 mission scheduled for launch in 2026. This ambitious endeavor will target the moon's south pole, a shadowy region believed to hold secrets about the moon's history and potential resources. A recently published paper by a team from the Chinese Academy of Sciences and the China Lunar Exploration and Space Engineering Center outlines the mission's scientific goals and the impressive payload required to achieve them. One key objective is to search for water ice within the permanently shadowed craters. While the presence of water molecules on the moon was confirmed by NASA's L-Cross mission in 2009 and SOFIA mission in 2020, Chang'e 7 aims to locate and analyze actual water ice deposits. The South Pole's frigid temperatures and limited sunlight create ideal conditions for ice preservation. Chang'e 7's reach extends far beyond water hunting, though. The mission will also investigate the moon's South Pole region's composition, surface features, internal structure, and even its magnetic field. Additionally, a fascinating experiment will explore the possibility of an Earth-Moon-based interferometer for ultra-high-resolution data collection. To tackle these diverse objectives, Chang'e 7 boasts an impressive 18 payloads. The mission will deploy an orbiter, a lander, a rover, and a groundbreaking miniature flying probe. This flying probe, along with the lander and rover, will ideally touch down near the South Pole's rim bathed in sunlight. The mission deploys a vast arsenal of scientific instruments, cameras, radar, water and mineral analyzers, spectrometers, magnetometers, a seismograph, and a volatiles detector. Chang'e 7's ambition lies in its scope and technological complexity. If successful, this mission will not only shed light on the Moon's south pole, but also pave the way for establishing a long-term lunar research station, furthering our understanding of our closest celestial neighbor. Will China's Chang'e 6 and 7 missions unearth even more lunar secrets? And could this be the dawn of a new era of lunar exploration, a collaborative effort or a race for resources? One thing's for sure, the Moon is no longer a silent neighbor. Join us next time as we continue to explore the possibilities space exploration holds for humanity's future.